Okay. Okay, so we discussed the two types of techniques, dependence, interdependence. In case of interdependence technique, no question of independent, dependent variable. You just have a set of variables and you do certain things with the variables to get some information or get some insights. In dependence technique or in supervised learning, you do have concept of independent and dependent variable. Then you also have like bivariate relationships or bivariate techniques or multivariate techniques. Anybody can tell me what is bivariate? Yes.
Bivariate is a classification technique where we have two different labels in the, the output label. There are two different classes. And multivariate is when we have more than two variables in the output label.
Uh, it, okay, a little bit confusion over here. In bivariate, you have one independent variable and one dependent variable. Okay, you have one single independent variable, one dependent variable, and of course, you want to predict the dependent variable on the basis of independent variable. That is what is your rationale of making the model. Okay, so you make a model in such a way that you will get an equation or whatever model in whatever format. Okay, because if you are using regression, you will get an equation. If you are using trees or something, you will get rules. But ultimately, that model will give you something to predict for. And what you'll predict is a dependent variable. Okay, so when you have a single independent and single dependent variable, that is called bivariate technique. Multivariate technique is when you have many independent variables, but a single dependent variable. Okay, your dependent variable is still same, one single dependent variable, but many independent variables. Okay, so like to give a very simple example, let's say last time we gave the same example, sales and advertising expenses. So sales is a dependent variable and advertising expense is an independent variable. And you do have a cause effect relationship. So you can, if I consider sales versus advertising expenses, it will be a bivariate, you can say regression. But when the moment I consider like, do you agree that it's not the sales only that will matter for the product? You will have multiple other factors. Okay, so you can have a price of the product, then you can say that how many salespeople you have, then how what is your R&D expenses, because the more you spend on R&D, the better is your product, and obviously it will have better sales. Okay, so how much you spend on R&D, then what is the competitor's price, and so on and so forth. So this all again are many causes, but you have a single effect called sales. Okay, so all these causes have an effect on the sales. So this all are multiple variables, which are many variables, which are independent variables, but ultimately you have a single dependent variable that is called sys. That is exactly multivariate technique. Okay. Now what you told me was for classification. Okay. And it is not called as multivariate technique. So in classification, you either have a binary classification or a multi-class classification. Okay. So when you do, there is something called logistic regression. So you have a binary logistic regression, okay, which is same. What do you mean by binary logistic regression? Your dependent variable, which is qualitative, has only two groups: yes or no, true or false, defaulter, non-defaulter, or fraud, not fraud, buyer, non-buyer, and so on. Only two groups. Then it is a binary logistic regression. You can also have a multi-class. Okay, so for example, I don't want to only predict yes or no or success or failure. I want to predict the credit rating. Okay, A, B, C, three different criteria. Then it is no more binary logistic regression. It is called multinomial logistic regression or multi-class classification. But do you agree that still your dependent variable is single dependent variable, which is credit rating? Do you get it? Yes, am I making it clear? So you may have a multi-class classification in classification type of problems, but though it is multi-class, it is not multiple dependent variable. Your dependent variable is same, which is credit rating, which has different groups in that. Okay, are you getting this?
Yes, ma'am.
Okay, because yes, it could be sometimes very confusing. So in a classification problem, you may have multi-class classification, but still it is called if in the, of course, when you have multi-class classification, obviously you will have multiple independent variables also. But even if you have only single independent variable and multi-class classification, you can clearly do multi-class classification with single independent variable. Okay, because that we'll see when we will do the discriminant analysis and logistic regression. Okay, but on the other hand, you may have only binary class, but multiple independent variables. Still, it is called multivariate technique. Okay. So even if you have a logistic regression or a binary logistic regression, where let's say I want to do the, I want to find out a defaulters. Okay. And you have multiple independent variables. Let's say age, income, debt to income ratio, and credit card debt, then other debts, etc. There are so many other variables which you have, and your single dependent variable is, whether the person is defaulter or not. So this is still called as multivariate technique. Okay, why? Because you have multiple independent variables. Is the distinction clear between classification, multi-class classification, and multivariate technique? Is it clear?
Yes, ma'am.
Okay. So let's see the different scenarios here. So let me just quickly uh, consider this. So what you have is, most of this you must have done in the last term. So tell me, what will you use if you have both variables? Do you understand what is qualitative means? Categorical or discrete variables are qualitative variables. Quantitative is generally numeric or continuous variables are called as quantitative variables. Okay. So both your variables are qualitative. Tell me, what do you use? Have you used it anytime? Yes. Okay. Have you used chi-square?
Yes, ma'am.
Okay. So what does chi-square do? What is the general null hypothesis for chi-square? No relationship between the two variables. Can you give me any example of chi-square? Any application? Chi-square, ANOVA, regression, logistic regression, all of these are very useful. Okay, they are extensively used in the industry, especially these qualitative variables are majoritarily found in marketing. Many things in marketing are basically qualitative. Okay, the demographics like gender, marital status, and so on. And then you do come across a lot of variables which have qualitative, which are basically qualitative, and then you will have to deal with them. You have to understand. You will do certain techniques. Can you give me any example of chi-square? Yes. There are many actually. There could be multiple examples. I would just give, let me just give a small simple example. Let's say, you want to do the packaging for the product, and there are like different groups. You have generally males and females. On the basis of whom that product is meant, you want to try the packaging. And let's say you have shortlisted few colors. Okay, so for example, green, blue, pink, then red and black. Okay, there are few colors you have shortlisted, and then you're asking a simple. You have taken some sample of people whom you're asking a simple question that which color is your favorite color? Okay, which is your favorite color? Which color do you prefer? And what will be the answer to this? No, whichever color. So someone will say green, someone will say blue, and so on and so forth. So what I do at the end of it is you actually find out the classification, or we call it as what table it is? Cross table, frequency table, isn't it? So you have gender here, colors here, and a frequency. Okay, how many males preferred green, how many males preferred blue, and so on and so forth. Now I want to understand, is there any relationship between the color and gender? Because if there is, then I will really seriously think about what color to be used for what type of product. So if I have to understand, then what will my null hypothesis will be, there is no relationship between color and gender. Okay, if it is rejected, and then on the basis of frequencies, then you can actually find out which color is more preferred by which gender, and then you can use that particular information for doing the packaging of respective product. Is this clear? Yes.
Yes, ma'am.
Okay, so that's one example. Of course, there are, as I said, there are multiple examples actually. Like you can also say that suppose if I want to find out the relationship between the attrition and department. Now tell me, what is attrition variable? Attrition or not attrition? Okay, the person has left or not, is left or not left. That's a yes or no. What type of variable is this? Qualitative, quantitative?
Qualitative.
Qualitative. And department? So do you agree that there will be some relationship between department and attrition? Possible? Certain
ma'am.
departments like
Yes, ma'am.
research and all, they don't have that much attrition as much as a sales department. Because sales people, they meet different people, they meet different people from the different competitors, and then they can get offers and they can shift jobs very easily. But not that may not really happen with someone having research job who's in the office and sitting in the lab and doing some research, etc. It might not be really possible that much. So attrition could be quite possibly low for the research jobs than and high for the sales jobs. It's quite possible. Okay, so what I'm trying to say is the department may have some relationship with the attrition. So department again is what type of variable?
Qualitative.
Qualitative.
Okay, so department is also qualitative. Then attrition is also qualitative. And then you want to understand the relationship between these two. What will you do? You'll do the chi-square. Is this clear? So then next is your independent variable is still qualitative, but the dependent variable is quantitative. Okay, what will you use here? Remember, you have done something called ANOVA. What was ANOVA? Analysis of variance. Have you done ANOVA before? Yes. You've done ANOVA, isn't it?
Yes, ma'am.
So tell me, when did you do? Can you give me any example of ANOVA? Just tell me. Just give any example of ANOVA. Then I'll explain. Qualitative and quantitative variables.
Ma'am, when a single phenomenon is explained by 2 or 3 different happenings, we try to understand that what component is coming from where. So basically, we try to reason the variance and see how much of it can be actually uh, understood, whereas how much is the error component.
Yeah, that's the logic of ANOVA. I mean, that's how the ANOVA is done. But I was just asking for any example of ANOVA, any application of ANOVA. ANOVA is extensively applied, marketing as well as HR. If the HR is full of ANOVA, MANOVA, have you heard about MANOVA? It's an extension of ANOVA. Okay, I'll discuss about it later on. But ANOVA, to at least you have used, and you have it's extensively used. So can you tell me any example? Okay, let me give an example. Suppose you are you are in a bank, and suppose there are 5 branches which are under you. Okay, you have to look after 5 different branches. So you have, let's say, branch 1, branch 2, branch 3, branch 4, branch 5. 5 different branches you have. And you want to understand, is there any relationship between the banks and the employee efficiency? Okay. Is there any relationship between branch and employee efficiency? Now, and suppose if I have quantified employee efficiency, okay, somehow I have been able to give a figure to employee efficiency for each branch, and I want to actually understand the relationship between these two. So tell me, what is like employee efficiency is the quantitative variable, and branch is what type of variable? Qualitative?
Qualitative.
Okay, branch 1, branch 2, branch 3 is purely qualitative variable. And I want to understand the relationship between this. So tell me, what is cause and what is effect here? What will have effect on what? Will the employee efficiency will determine the branch, or will the branch determine the employee efficiency?
The branch will determine the employee efficiency.
Yes, absolutely. Okay, so that means branch is an independent variable and employee efficiency is a dependent variable. Okay, so your independent variable is qualitative, dependent variable is quantitative. Then you will use ANOVA. Okay, so indirectly, doesn't it mean that I want to understand, are all branches performing equal, or are there some branches which are significantly different than each other? Isn't it?
Yes, ma'am.
Okay, so that is exactly what you want to do when you want to do the ANOVA. And that is exactly understanding relationship between branch and efficiency. If there is no relationship, that means all the branches are equal. There is no, the efficiency will not differ on the basis of which branch you pick. But if there is difference, that means different branches are having different employee efficiency. That means the branches, there is some relationship between branch and employee efficiency. Is this clear? So it's like exactly same. ANOVA actually does comparison of means. And because you have groups, what you do is you find out different groups and find different group means. If the means are same, that means groups are same. There is no difference on the groups on the basis of the dependent variable. If the means are different, that means there is difference in the groups. Is this clear? Please ask any questions if you have. Okay. Now this is something which you have not done unless you had taken the uh, analytics course, which is something called logistic regression. Okay. So logistic regression is typically used when your dependent variable is qualitative, but independent variables is quantitative. Okay, we have an independent variable quantitative. In fact, there are two types of techniques, parametric techniques and non-parametric techniques. Have you studied any non-parametric technique? Can you give me example of any non-parametric? Have you heard about non-parametric test? Okay, so I can just give you a very simple understanding logic, which will make it very clear what is parametric and what is non-parametric. Now you have two types of variables. You have qualitative variables, quantitative variables. The quantitative variables are also called as metric variables, and qualitative variables are called as non-metric variables. Okay, so when you use metric variables or metric techniques, okay, what do you mean by metric techniques? Tell me any quantitative variable. Can I find mean? Can I find standard deviation? It's a quantitative variable. Okay, so any quantitative variable, I can find mean, I can find standard deviation. So if I use any technique which uses mean and standard deviation, that is basically metric technique. And that is basically called as parametric test. But when you have a non-metric variables or you have non-metric methods, okay, so chi-square is a non-metric test. Then you basically use something called non-parametric test. So for metric, you use parametric test. For non-metric, you use non-parametric test. Okay. So what's the difference? Difference is parametric tests are very much reliable. They are very robust. Okay. I mean, they give very reliable results. As against non-parametric tests, they do not give reliable results. They are not as much, you can say, robust as well. There are multiple parametric tests, non-parametric tests available. As against parametric tests are very restricted. Okay, but non-parametric tests are huge in number. In fact, there is a book in the library, 100 non-parametric tests. Okay, there are multiple non-parametric tests. So even suppose instead of ANOVA, if you want to do, there are multiple tests which can do ANOVA, but they are non-parametric. Okay. Generally, you will try to do a parametric test because parametric tests are more reliable and more valid. Okay. But many times what happens, parametric tests comes with assumptions. Okay. And suppose if those assumptions are not true, or if your data has some problem and you are not really sure about your results of the data, then you cannot do parametric tests. You have to rely on non-parametric tests. Okay. So when either the data is non-metric or if the methods is non-metric. What do you mean by non-metric method? Metric method is finding using mean and standard deviation to do analysis. If you see, the mean and standard deviation is the base of any analysis. Even for doing ANOVA, you find mean standard deviation. Even for doing regression, you find mean standard deviation. Even for factor analysis, any parametric test, it starts with mean and standard deviation. But when your data is non-metric, okay, or qualitative, can you find mean of a qualitative data? Not,
No,
isn't it? You can't find mean of qualitative data. So if you can't find mean, can you find standard deviation? Not possible. So you can't use mean and standard deviation. Then you need to use what? Because in qualitative you can count. So you use frequencies, you can use, when you especially use only frequencies, or do not use mean and standard deviation to do the to find out the to do the calculations or to do the analysis, then they are basically non-parametric tests. So if you remember chi-square, what you do, you find out frequencies, observed frequencies, and expected frequencies. Do you calculate anytime mean or something? No, isn't it? You just used two types of frequencies, expected frequencies and observed frequencies. And you do the chi-square. And that's why it is a non-parametric test. Okay, there are many non-parametric tests like run test. In run test, you actually calculate the run. Okay, like how many runs it happens in the, like you have true, 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 false, 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 etc. So you can actually count the runs, and on that basis, you can actually check whether this particular data is random or not. Okay, so that another test you have. So you have multiple tests which either uses non-metric variables or it uses non-metric methods. Then it is non-parametric test. Okay, but most of the times you will prefer to use parametric test, but if the parametric test fails, for some reason you can't use parametric, then you use non-parametric test. Okay, so for example, when both variables are qualitative, can you use parametric test? Can you find mean and standard deviation? No. So you're forced to really use chi-square, which is a non-parametric test. Is this clear? Last one is, of course, regression. Okay. So logistic regression is typically used when your dependent variable is qualitative and independent variable is quantitative. Okay. You need quantitative independent variables. The typical use of logistic regression is in credit rating. Okay. Majority of the credit rating algorithms, they use logistic regression extensively. Okay. It works very fine with the linear relationship. If you have a linear relationship, logistic regression and regression are the most appropriate choices. If you do not have a linear relationship, then you may have to use some other methods. Is this clear? This is about bivariate. Same thing you could do for multivariate. Okay, so what is for multivariate? A little difference here. Instead of a chi-square, you have something called trees. Now, in fact, trees is the techniques which you can use for all four quadrants. Okay, we'll discuss trees in our syllabus, in our course, basically. Trees are like no restrictions on dependent or independent variable. You can actually use trees for all four possibilities, but trees work best when your majority of the variables are qualitative. Okay, especially when the independent variables are qualitative, tree works like magic. Okay, because it is really meant for qualitative variables. It works best with the qualitative variables. Now, if you have qualitative independent as well as dependent variables, and you have multiple independent variables, okay, and a single dependent variable, what we would generally use is called classification trees. There are two types of trees. This is classification problem. This is classification trees. If I have to use trees here, I will use regression trees. Okay, you have a classification trees, regression trees. So if your dependent variable is qualitative, it is classification trees. And if your dependent variable is quantitative, it is called regression trees. Okay, so I could use, instead of NV ANOVA, I could use also trees. Okay, so trees is generally better option than NV ANOVA. But yes, you can use NV ANOVA also. What is NV ANOVA? you have many independent variables. So two-way ANOVA, three-way ANOVA. So if you have two independent variables, it will be two-way ANOVA. Three independent variables, three-way ANOVA, and so on. Okay. So that's basically your n-way ANOVA, multiple independent variables. All independent variables are qualitative, but your dependent variable is quantitative. Okay. So there was someone asked question in the previous class that what happens when some of the independent variables are qualitative and some of them are quantitative? What will I do? Okay. So the answer for that is you will use something called analysis of covariance, ANACOVA. Okay. So it's a separate technique where your dependent variable has to be quantitative. Independent variables, some of them are qualitative, some of them are quantitative. Okay, then you will use something called ANACOVA, that is analysis of covariance. In fact, the binder has all this. It also has something called MANOVA. MANOVA is very rare. Most I have used MANOVA only in HR actually. HR uses MANOVA to certain extent, but other than HR, I have not seen many people using MANOVA. Anybody has heard about MANOVA? Anybody is aware about MANOVA? Now remember here, when we say multivariate techniques, though I have multiple independent variable, your dependent variable is single. MANOVA has multiple dependent variables. Okay, you have many dependent variables and many independent variables. Then what you use is called multivariate analysis of variance. Is this clear? Okay, multivariate analysis of variance, which is used when you have multiple independent variables as well as multiple dependent variables. To give a very simple example, because in the previous class someone asked, your class is not really responding, so I'm sure that if I give you example, you will understand it better. So how do I really, to give an example of MANOVA, let's say if I want to study employee performance and employee satisfaction, okay, these are my both dependent variables, and my independent variables are, let's say, gender, salary range, then designation, department. These are various independent variables I have, and my dependent variables are employee satisfaction as well as employee performance. Okay, I don't want to study them in sync separately. I want to study them together. Okay, that's exactly what is the difference. Then what I would use is MANOVA. Okay, multivariate analysis of variance, where I have two dependent variables and multiple independent variables. Is this clear? So logistic regression is basically same here. I mean, if you see, these are the only two columns which are different. Instead of simple regression analysis, it is a multiple regression analysis. Okay, so multiple regression analysis when you have many causes or many independent variables, but a single dependent variable. Any questions so far? This is very important because you will be getting data and you'll have to figure out what to do with the data. Okay, I mean, that is the most important. Depending on obviously your objective and what type of the data you have, you would be picking up the right, you can say, tool to do right things. So what the question is, can I use logistic regression here when you have majority of the data? I mean, if you have all the data qualitative, technically, yes. Can you give me any example of this where you have many independent variables, one single dependent variable, and all variables are qualitative? Can you think of any example, especially in marketing? Yes. So have you heard something called sentiment analysis? Yes.
Yes, ma'am.
So what exactly is sentiment analysis? Like generally you want to understand the sentiment on the basis of some social media feed. Okay, so could be a Twitter or a Facebook feed or something. So what you have as an independent variable is words. Okay, what you have in a any social media is words. Okay, you have a text or a tweet or something like that, which has just words. So your independent variables are words, And a dependent variable is like sentiment, whether it is positive or non-positive or negative or non-negative, or it's any kind of sentiment you want to check. Okay, so that's basically the sentiment analysis, which is having all variables which are qualitative. Okay, so trees works best with that. But technically, can I use logistic regression if your variables are qualitative? Technically, yes, I can actually convert each variable into dummy variable. We'll come to that. What is dummy variable and all. We're going to discuss again in detail as well, because your assignment has a lot of dummy variables. You should understand dummy variables treating, etc. But yes, you can convert the variables into dummy and use in the logistic regression. But will it give you very good results? Not necessary. Okay, most of the times for non-linear models, trees work better. Okay, so the rule is if you have majority of the variables qualitative, then the trees work better. And if the majority of the variables are quantitative, then logistic regression works better. Okay, especially if you have a linear relationship. What is linear relationship? Let's say if I consider, let's say income and disposable income. Okay, so disposable income is my dependent variable, income is the independent variable. Now, do you agree that there is a linear relationship? High, as in whatever proportion my income increases, in a similar proportion, my disposable income also will increase. So that's basically the linear relationship. So wherever there is a linear relationship, parametric methods, they would work better. That means logistic regression or regression, depending on what is the type of the dependent variable. Okay. But if you do not have a linear relationship, for example, if you have words, do you really think words have linear relationship? If you have independent variables as words, they don't have really linear relationship. So the logistic regression may not really work well. The trees would work better in that case. Okay, so depending on what type of data it is, what type of relationship you have, you would use a respective model. Now, when I say if you have, you can say some of the variables are qualitative and some of the variables are quantitative, what will you do? So how can I use qualitative variables in logistic regression? Is it possible? Or can I use quantitative variables in regression analysis? Qualitative, sorry. Can I use qualitative variables in regression? Yes or no? So suppose if I have a variable called gender, can I use it? Male and female? Can I use this gender in the regression? Suppose I'm doing, let's say, what should I give? Example. Okay, so I'm actually predicting the credit score, okay, which is a number. I want to predict the credit score for individual, and I have a variable called gender. Now, do you agree that gender will matter on the credit score? Do you agree? There will be some relationship between gender and credit score. So if I have a gender and I want to use it, can I directly use it? Suppose if I make male as 1, female as 2, is this a qualitative variable or quantitative variable? If I define male as 1
Qualitative.
and female as 2, we call it as nominal variable. Okay, nominal variable. Basically, gender is a nominal variable. Male, female, there is no, you can say, order, neither order nor fixed distance. Okay, fixed distance is basically quantitative. If there is a fixed distance, then it is a quantitative variable. If there is order, obviously. So can I say male is better than female or vice versa? Not possible. Okay, so no order and no fixed distance. That's why it is nominal variable. So if you have a nominal variable, can I find the average of on a nominal variable? Suppose if I have 100 observations, okay, and I have like 1s and 2s, etc. So I add all and divide it by as many added. That is my average. And suppose my average comes out to be 1.8. So can I have any useful meaning of this average? Possible? Yes.
No, ma'am.
This average will have no meaning. Why? Because this is a nominal data. Remember, average can be calculated or average can be meaningful only for the quantitative data, not for nominal data. Okay. But when I convert this variable into dummy, what is this dummy variable? It's a special variable where you can give only two options, 1 or 0. Okay. So suppose if I say male is 1, female is 0. Okay. Generally, it is something like presence and absence of certain characteristics. So male is presence of male and female is absence of male. That is basically female. So that is how it is considered. Okay. So presence is 1, absence is 0. So if I do calculate it like this, and now if I take an average and suppose the average is, let's say 0.7, will this 0.7 has some meaning? Are you getting this? If I add and divide, and if I take an average, tell me what is the meaning of this 0.7? Will it have any meaning?
Yes, ma'am.
Yes, it will have meaning. Tell me what is the meaning? It is 70% are male.
70% male.
Yes. Okay. If it is 0.8, what is the meaning? 80% of the people are males. Okay. So it does have a meaning. So what it means is you're trying to convert a qualitative variable into a dummy variable, which is usable in the model. Okay. You can't use if it is 1 and 2. It is completely incorrect. You may do it. Your software will give you the result, but it is incorrect. It's not really correct to do it. Okay. You will get all, you can say, incorrect results if you use nominal data in the analysis. Okay, that's a disaster. But if you convert it into dummy, then it becomes meaningful. Okay, the only problem is if you have many groups, then how do I do it? So for example, same example I took, department and attrition, and suppose I have 5 departments, A, B, C, D, E. So how do I manage this problem? How do I actually convert this into dummy? Again, if I do 1, 2, 3, 4, 5 and take an average or anything, can I do it like that? Will it work? If I do 1, 2, 3, 4, 5 and take an average and use it in the analysis, it won't work. Okay, you can't use nominal variables. You have to specially use dummy coded variables. So what is dummy coded? Now tell me how many groups were there in this case? 2 groups. And how many variables you used? 1 single variable. Okay, you said x1 either 0 or 1. If it is a male, it's a 0. If it is a female, it is, sorry, if it is a male, it is 1. If it is a female, it is 0. That is how you created the variable. So you needed only 1 variable for 2 groups. So how many variables you need for 5 groups?
4 variables.
Absolutely. Okay, so you need 4 variables, x1, x2, x3, x4. So x1 I can say is 1. So only at presence of A, all others are absent. Then presence of B is x2, all others are absent. Then presence of C will be x3, all other absent. And the presence of D is x4, all others are absent. So this E is basically absent all. Okay, so just like absence of male was female, absence of all A, B, C, D is E. That is how you will see. Anyway, I will discuss that in extensive detail when we go into regression analysis. Okay, but this is how you treat it. And remember, once you convert it into dummy, it is no more nominal variable. It is a special category variable called binary variable, dummy variable, or dichotomous variable. Okay, these are the names, different names for the same thing. But yes, it becomes that variable, and only if it is dichotomous or binary variable, it is allowed in respective analysis. Okay, I can use it in logistic regression, I can use it in multiple regression, I can use it in factor analysis, and so on. But otherwise, I cannot use any qualitative variable in any of these techniques, neither in cluster analysis nor in factor analysis. Cluster analysis also on the basis of distance. Distance means pure quantitative variables. Okay, so you can't use any qualitative variables in neither factor nor cluster nor logistic regression, discriminant analysis, not possible. Okay, unless you convert it into binary or dichotomous variable. Is this part clear? Okay, so let me just quickly go to SPSS. So when you open SPSS, you get a blank screen. Okay, so SPSS has typically 3 views. You can see this is highlighted data view. This is basically your data view. You also have a variable view. This is a second view. You can see variable. Something different is there than here. And the third view is basically called as output view. Okay, so you have a data view, variable view, and output view. Now you can't see output view because you have not done anything, and you're not. The moment you do something here and do analysis, the analysis is put in the output view. Okay. SPSS saves two different types of files. This is called as data file, which is saved as .sav file. It also saves something called output file. So output view is basically in a completely different file. And that output file is saved as a .spo file. Okay, so there it's completely different, independent, and there is no relationship between your data file and output file. Okay, so you can have any permutation combination possibilities. Like for example, you can create a data file and create multiple output files from the same data file, or you can do vice versa. You can create multiple data files and put output in the same output file, and so on. Okay, the reason it is differentiated, the reason data file is separated from output file, because your data is very sacrosanct. You don't share your data with anyone, irrespective of whatever you want to do. Okay, whether you are doing research, whether you're in the industry, you generally have non-disclosure agreements. You are not supposed to share your data with anyone. Okay, but you can always share your output with someone. Okay, so you want to take some advice, you want to share something, you can always share the output. So that is why SPSS separates the data file from the output file. So you can actually separately keep a data file and separately keep output file, and you do not need a data file to open the output file. Okay, so you can open the output file irrespective of whether data file is open or not. Okay, so you can always send your output file to whoever you want to send, and you can take feedback on that, and you can share your information and so on. But you will never share your data file for sure. Okay, that is why there is a complete distinction between data file and output file. Now, the full form for SPSS is basically Statistical Package for Social Sciences. That's nothing but SPSS. Typically, it was made for social sciences kind of projects where you have a questionnaire kind of design. Okay, so all of you, I'm sure, are aware of questionnaire design, where you define a questionnaire, then you administer that questionnaire to multiple people. Okay, and you ask the same question, of course, to multiple people, and you get the answer on the same question, and you compare and contrast those answers, and you do some analysis. That is exactly the method which is followed for a questionnaire kind of design. Okay, so you have a single questionnaire, you give it to multiple people. For example, I create a questionnaire, and suppose there are 20 questions in the questionnaire, and I give it to multiple people, and I got 1,000 responses back. Okay, I got 1,000 responses of those 20 questions. Okay, so then I actually enter that data in this particular file, and then I start doing the analysis. Now, before I enter this file, can you see here variable, variable, variable? I'm in the data view. Okay, so each column represents one variable. Okay, each column represents one variable, and each row represents one observation. Okay, which is called in SPSS terminology, each row is called as case, and each column is called as variable. Okay, what is case? Now remember, when you say questionnaire, do you agree that before I design a questionnaire, I decide the unit of study? Now, what is the unit of study? Who exactly is going to answer this question, or who is my study subject? Okay, so for example, if I'm studying a company, then my unit of study is company. Okay, in that case, each observation will have information about one company. If I'm talking about product, if I'm studying some products of some company, then each observation will be one information about the product. Or if I'm giving the questionnaire to, let's say, people, then each person's response or each person is basically one row. Okay, or each case is basically one person. So each case is nothing but each unit of study. Okay, so if I have 1,000 responses, tell me how many rows I should have in the SPSS file?
1,000.
Yes. Okay, absolutely. So you'll have 1,000 rows in the SPSS file, and there should be one-to-one correspondence. if there are 1,000 responses, you should have exactly 1,000 rows, not more, not less. Okay, each row should represent one response. If you have 20 questions in the questionnaire, you will have at least 20 columns in the SPSS. Okay. What do you mean by at least 20? Can you think of any situation where you will have more than 20 columns?
Ma'am, in case we create dummy variables.
Okay. Actually, when you create dummy variables, yes, there will be multiple columns. But I'm talking about when you, suppose I administered the questionnaire and I got the responses, and now I'm entering the data in the SPSS. So I'll not create dummy variables right then. Okay, dummy variables will be created during the analysis stage. Okay, so that of course, what you're saying is true, but that's not exactly what I'm trying to ask. I'm saying that if there are 20 questions in the questionnaire, I'm just entering the data, okay, from questionnaire to here. I'm not doing any analysis on that. I'm just entering the data. So tell me when I said there are at least 20 columns will happen, what are the situations when there will be more than one column for one question? Yes, can you think of any situation where there will be only one question asked, but that question will go as a multiple column? Is it possible?
Ma'am, may I try?
Yeah, please.
Ma'am, sometimes like we have question like yes and no, and if there is a no and explain why, something like that. They give explanation as in text format.
Okay, so there are certain rules of an this one, what you call questionnaire design. So generally you don't ask two questions in the same question. Okay, so if it is no, yes, I understand. There will be a question where okay, you're saying that in the same question, if there is no, you have to answer the reason. Yes, possible. In fact, even there is something called others. Sometimes it is given, it is somebody else also said that if it is others, they ask, please specify what is others. You know, that also can be, yes, Murli?
Work or education background, like you have a days
Education background.
or work ex. Work ex you have to work ex and education background and the same.
Okay, so I mean, yes, all of you are right. So my answer in one line is when you have multiple answers. Okay, so you have a multiple choice questions, you have multiple answer questions, because if any question has more than one answer to that question, you cannot put it in the same column. Okay, you'll have to have a separate column. So the typically, I would say in the typical, I mean, what you all gave was very exception, but in a typical scenario, do you understand the difference between checkbox and a radio button? So what is a radio button? You can only choose one. But the moment you have a checkbox, you can have a multiple choices. Okay. So whenever you have a checkbox kind of question, okay, that also you have to put a multiple columns. For example, they ask you what are your hobbies? So I give it 4 choices: reading, then watching movie, listening to music, or traveling. Okay, these are the 4 choices I have. Now, is it necessary that people will only answer one or only answer two, give 2 ticks or 3 ticks or etc.? Someone could give all 4, someone could give any permutation combination of those ticks. So how do I enter that data in SPSS? So what will I do? Any ideas? How do I enter something like this?
We create one variable for each option and then mark it as 1 or 0 based on
Absolutely. Absolutely. Okay. So what you do is you create a separate variable for each options, because you have a multiple options. The respondent can answer any permutation combination. So you're not going to really do in a sequence, okay, like this or this or this or this, etc. Not possible. You cannot really use one single variable. You will use multiple variables. It will be a binary variable. Okay, 1 or 0, whether it was ticked or whether it was not ticked. Okay, so that is how you manage it. But let's say for simplicity, we assume that, okay, there are 20 variables and all of them are single answers. There are no multiple answers questions. So there will be exactly 20 variables in the, or 20 columns for the SPSS. Do you agree? So columns represent variables, rows represent cases. Okay. So in Excel, when you open Excel, you can start typing, but because this is a little bit different kind of software, it's a very simple software. Initially, you might find little bit discomfort because it's a new software. Anything new will be discomfort initially, but once you get used to it, you will become expert in this. It's a very easy software, and that's why I have picked up this. Okay, because I don't want to waste too much time on learning software rather than learning concepts and techniques. So in a variable view, you can start naming the variable. So I'm going to pick up a file. Okay, I have used this particular, I'm going to take this file as the example for SPSS or a case for SPSS. So this file is nothing but it's a online second-hand sale data of vehicles. Okay, so it's some US-based site it is, which sells second-hand vehicles, and it's their data for second-hand sale vehicles. And the assumption here is all these vehicles were sold in 2019. Okay, so 2019 is the year. So this all data, I think there are 150 observations here. All these 150 observations of or all these 150 cars. Number one, they were second sale car. Okay, it's not first sale, but it's a second hand car. Okay, and the second thing was it is all of them were sold in 2019. Okay, and we call it as a first sale car. What do you mean by first sale? So somebody has bought a car and now selling the car first time. Okay, so all these are first sale cars basically, and they were second hand. Okay, they were not new cars, they were second-hand cars, but for sale, second-hand cars. That's what is the assumption. So just to give a brief about the data, you have something called manufacturing year. Though it's mentioned year here, basically it is a manufacturing year. So what was the year of manufacture for that particular car? Then the model, what model that car belonged to. They have considered 3 different models like SEL, SE, and SES. Okay, so these are the 3 different models, maybe of the same brand. Okay, like if you consider any brand in India also, you will have multiple models. So suppose you have chosen 3 models of a particular brand, that is exactly they have done 3 different models of the same brand. Then you also have the price. What price? This is prices in dollars actually, because as I said, this is US data. So the price of the second-hand car, that's what is this price means. Mileage is how many miles the car was run before it was sold. That becomes the mileage. Okay, it's different than our mileage. We generally say, when we say mileage, it is miles per liter, but this is a different mileage altogether. Okay, how many miles the car was run before it was sold. Color and transmission. Okay, transmission is whether automatic or manual transmission. So these are the different variables you have. Now you can directly import this data in SPSS, but you can also type in SPSS. Okay, so I'm just going to quickly, I know this is really outdated because even if you do questionnaire design now, hardly anybody is going to really get a questionnaire in the hard copy and somebody is going to enter. It's most of the surveys are now online surveys. Okay, you have a surveymonkey.com, and there are multiple survey sites available where you directly get the .excel file. Okay, Excel file basically, or CSV file, but you don't really need to do the data entry. But still, if you ever needed to do the data entry, I can tell you that how exactly you will be doing. I'll not spend too much time on this. So this is the name of the variable. There are some restrictions on the name, not on the characters. You can have as many characters, but the restriction is you can't have a special character. Okay, no space, no question mark, no other special character other than underscore. Underscore is the only one which is allowed. So because the special character is not allowed in name, okay, so names could be very vague. Okay, because most of the times only after space is there you can understand the name. So generally underscore is used to make it more readable. Okay, But you also, what we generally do is you put whatever information about that variable in label, because label has no restrictions. Okay, in fact, the label is there because name has restrictions. If the name didn't have restriction, you don't need any other variable called or option called label. So labels can have any special characters, any number of characters. So you can actually type anything you want in the label. So generally there are some best practices. The best practice is to put the question asked in the questionnaire in the label. Okay, so that you know exactly what was the question. So that whenever you do the analysis, you don't have to really cross verify the questionnaire again and again to do the interpretations. Okay, you know exactly what was the question. So you would generally put a question from the questionnaire as a label. Okay, so that is your for cross reference. Now there are different types of variables actually. You can say you have all these types of like you can have comma type, dot type, scientific notation, date, dollar, custom currency, string. Just like Excel you have. Generally we will be using numeric, date and string. Okay, these are the three different types we are going to use. We're not going to really bother about the currency and etc. So what is string basically? String is nothing but alphanumeric. Okay, whatever is alphanumeric in Excel is a string over here. So anything which does not have number in it, okay, becomes the alphanumeric kind of variable. So presently this I will keep it as numeric, though I don't want decimals. So let me just remove the decimals here. Label, as I said, because name has restrictions, I can have anything in the labels. Okay, so I can say manufacturing here, I can give a space over here. The values is something which is very useful only for a qualitative variable. So here is not exactly a qualitative variable, so I'm not going to use anything here. Missing, if suppose there's a whole lot of things you can do with the missing data. What is missing data? Something which is not available for that particular cell. Okay, so you can actually do some basic missing data analysis and replace the missing data with that particular value. Okay, so that you can say. Columns is obviously
Ma'am, can you explain again what is values column?
okay. Values column I can explain only with the next one. Suppose if I have model as the next value. Now tell me what type of variable is model? Is it qualitative or quantitative?
Quantitative.
It's a qualitative variable. So I have two choices here. I can either define this as a string. Okay, I can say string and I can start typing SE, SEL, SES, etc. Or alternatively, I can define it as a numeric and specify values, what is what. Okay, so if I say 1 is SE, then I can say, okay, 2 is SEL and 3 is SES. This is called as mapping. Okay, so what I'm doing is, though the variable is qualitative, I'm mapping that variable into some numbers so that it is easier for the software to deal with it. Do you agree that for any software, the numbers are much easier to, you can say, sort and search and etc. than string? Do you agree? So if I directly define it as a string, it becomes very difficult for us. I mean, internally it takes a lot of processing time to do those kind of things. And if I define it as number and if I give a mapping like that, though it's a qualitative variable, software knows it's a qualitative variable. It is very easy for the software to search that variable. But if I do any analysis, it will not show me 1, 2, 3. It will always show me SE, SEL and SES. Okay. So there is absolutely no restriction here. There is no disadvantage. It's only advantage. Okay. So let me just remove this decimal signs because it doesn't make sense to have decimals. So remember, when you created a variable in the data view, you will create a variable in the variable view and that variable will be viewed in the data. Okay. So for example, if I say model, I can just type 1, okay, or 2 or 3. Okay, because there are 3 I have defined. And you also have something called view option. So you can just click on view and you can toggle between value labels. So if I give value labels, you can see So what happens is it tells you that, okay, that one was mapped with what, that two was mapped with what, and etc. Now, do you agree that it is easier for me to do the data entry here rather than in Excel? Because I just have to do 1, 2, 3. It gives me better accuracy. It gives me a very easy way of doing it. In fact, there is also best practice here. So generally, when you have a questionnaire, you generally, for example, someone asks, what is your qualification? Okay. And you have given different highest qualification, and different values are given. Okay. So let's say MBA and etc. etc. So you retain the values exactly same sequence as you have given in the questionnaire. So first is MBA, then you'll say MBA is one. Second is, let's say MCOM, then two will be MCOM. So you retain the same sequence so that whoever is doing that data entry becomes very easy for that person to put those values 1, 2, 3. Okay, but by doing so, you save time, you increase the accuracy, and you make sure that there are no errors in the while data entry. Okay, that's why it's always easier to enter data in SPSS than in Excel, because using these techniques, you would actually make sure that it will be very easy. But at the same time, though I have actually converted this variable, though it's a numeric variable, it is actually as good as string variable. Why? Because internally it is numeric, but for externally, for even putting wherever you use this in any output, it will not show you 1, 2, 3. It will always show you the actual value of that variable. Okay, that means SC, SCL, and SES. Is this clear? So values is something is very useful. It's, in fact, there are certain analysis. It will not allow you to use strings. For example, it will not allow you to do ANOVA unless you define the variable as numeric. You have to have a numeric variable and value coded variable if you want to do ANOVA. If you don't have that, you will not be allowed to do the ANOVA. Why? Because it becomes easy for the software to really do any kind of analysis, internal analysis, if it is numeric. Is this clear? Anyway, next time we will actually import the file and start doing the analysis. Okay, so you can very easily import the Excel file. Like we will continue next time. Okay, we almost